All right, so in this video, I'm going to solve these trig identities over here. So let's take a look at the first one over here. The left side is more complicated, so I want to work with the left side. And what I notice is I have double angle formulas over here. Now there's three different double angle formulas for cos 2x. You have cos square x minus sine square x. You have 2 cos square x minus 1. You have 1 minus 2 sine square x. So in order to figure out which one you have to use here, you gotta take a look at the whole top. You see there's a plus 1 over here. And you look at the other side, there's no plus 1, there's no minus 1. So we want to get rid of this plus 1. And if we pick the formula 2 cos square theta minus 1, and then we have the plus 1, we know that the minus and the plus 1 will cancel each other out. And that's the goal in this problem. So that's why you know you got to pick 2 cos square theta minus 1 for cos 2x over here. Denominator sine 2x only converts to one thing, 2 sine x cos x. And now this minus 1 and plus 1 cancel each other out. Also, that's an x, not a theta. I wrote a theta from the original formula. So now I'm just left with 2 cos square x divided by 2 sine x cos x. Now the two 2's can cancel, and the squared will cancel. So one cos from the top, one from the bottom. So I'm just left with cos x over sine x, which is basically the same as cot x, which is the same as the other side. Second example is pretty similar to the first one. For sine 2x, there's only one thing I can consider changing that to, which is 2 sine x cos x. And for cos 2x, again, I have three options. So remember, I want to get rid of this one. This one is positive as well in this example, but there's a negative here. So if I convert this into 2 cos square x minus 1, and I distribute this negative into the bracket, it will turn into a double negative, which will make it positive, and I'll have 1 plus 1, which is 2, which I do not want. Remember, I want to cancel this 1. So in this case, I'm going to switch this to 1 minus 2 sine squared x. And when I distribute this negative into this bracket, the two 1's will cancel out. So let me actually do that next. Let me distribute the negative into the bracket. So I'll have 1 minus 1 plus 2 sine squared x. 1 minus 1 is 0, just cancels out. So I'm just left with 2 sine x cos x divided by 2 sine squared x. And now I can cancel the 2 from the top and the bottom. And I can also cancel a sine from the top and bottom. So again, I'm just left with cos x over sine x, which is basically cot x, which is again the exact same as the other side. Let's take a look at this third example over here. In this third example, both sides are kind of equally complicated. I could work with the left side, I could work with the right side. I'd still pretty much end up in the same solution, no problem. I'm just going to work with the left side. I'm going to find that a bit easier to expand. So I'm going to start by writing out my bracket 2 times. Now I'm going to expand these two brackets out with FOIL. So I have sine squared x plus sine x cos x, that's the two outside terms, and then plus sine x cos x, that's the two inside terms, and plus cos square x. And now I'll combine like terms, sine squared x plus 2 sine x cos x plus cos squared x. Now we can convert 2 sine x cos x into sine 2x using my double angle identity. And then this is almost similar to this. I'm just going to reorganize this and write it as sine square x plus cos square x plus sine 2x. And then we know by another identity that sine square plus cos square is just 1. I'm left with sine 1 plus sine 2x, which is basically the same as the other side. And then we come to this last question over here. This one is actually a really easy question if you know what to do. If I look at this question, the left side is much more complicated than the right side. So I'm going to factor the left side here, and I'm going to factor it by difference of squares. If you know this step, this problem becomes extremely easy. So all I did was square root each of these terms and have opposite signs in the brackets. That's just your regular difference of squares over there. The same as if you have x squared plus y squared, minus y squared, it's x plus y times x minus y. So knowing your factoring method, your difference of squares is really good. It's really important to these questions. Then I know that sine square plus cos square is just 1. And I know that cos square minus sine squared is just cos 2 theta. It's one of the identities for cos 2 theta, and 1 times cos 2 theta is just cos 2 theta, which is again the exact same as the other side, and we've proved all these trig identities.